Welcome to binomial expansions. Expanding binomial expansion using combinations. Example number 1. Expand the binomial expression using combinations. Here's a binomial expression. X minus 1 over x2 raised to the power 4. Solution. First, we write down the formula for expanding binomial expressions using combinations. The formula is like that. A plus b raised to power n. We start by first writing down the binomial coefficient for the first term, which is n combination 0. Notice the binomial coefficient for the second term is this one, n combination 1, then n combination 2, n combination 3, and so on and so forth. Again, be reminded we're simply counting, so we're counting from 0 to 1 to 2 to 3 and so on and so forth, and the n there represents the power. So we've got n representing the power here. On every n there, power n representing that power. Okay, then we raise a to the highest power, which is n, okay, in the first term, and then we keep subtracting 1. So we're going to have n minus 1 here. We subtract another 1, so we're going to have minus 2. Subtract another 1, we're going to have minus 3, and so on and so forth. And to b, the second term, we start counting from 0 and we keep adding a 1 as we progress. So the second term will be 0 plus 1, which will give us 1, power 1 there. And then 1 plus 1 will give us 2. Then 2 plus 2 will give us 3, and so on and so forth. Okay. Then we compare the question at hand to this formula which we have written there. Okay, so here's the question. X minus 1 over x squared raised to the power 4. So when we start comparing, the first thing that we're going to notice is that a is equal to what? X, where a is positioned here. A here is equal to what? The x there. Okay, and then our b is going to be equal to, notice we are taking the negative sign into consideration as well. So b is equal to minus 1 over x squared, minus 1 over x squared. And lastly, in our comparison is n, the power. The power there is equal to 4. So n is equal to 4. Okay, so after we've done our comparisons, what we're going to do therefore is we're going to substitute these values into the formula. Okay, so here we are. N there we said is equal to 4, so we're going to write down a 4 there. We've got 0 there for that 0. A is x, so we've got x there. N is equal to 4, so we've written down a 4 there. And b is minus 1 over x squared, okay, and it's raised to the power 0 there. Okay, now notice I have enclosed the minus 1 over x squared in brackets. The reason why I've done that is that every time you come across a negative sign, it is good practice to enclose it into brackets. Okay, that's what I'll say at now. I'll let you're going to see a reason why as we progress in the expansion. Okay, so for the second term, again, our n there is equal to 4 from that. Okay, and according to our formula, we're going to subtract for the second term n minus 1, so we're going to have 4 minus 1, which gives us what? 3 there. We've got a 1 there, 1 there. B is equal to minus 1 over x squared. Okay, and so on and so forth. We're simply substituting. So again, n is 4. We got a 4 there. N is 4 there. 4 minus 2 is 2. And we've got a 2 there. And that's our b. Alright. And we progress like that. Alright. Then what we're going to do is we're going to note a few things here before we progress with simplification of the expansion. The first thing we're going to note is that the powers on each term of the expansion should always add up to 4. So we are saying that the power on x is 4, the power on the second term is 0. If we add 4 and 0 should give us 4. The same here, the power on x is 3, the power here is 1. If we add 3 and 1 we get 4. If we add 2 and 2 we get 4. If we add 1 and 3 we get 4. If we add 0 and 1 we get 4. Okay, so when you're expanding a binomial expression, the power should always add up to the power that you want to expand the binomial expression to. If it is not adding to that, you've made a mistake. Note number 2, the power presenting. The second thing I want you to note is that the power on the second term and the number of combinations are the same. Okay, so the number of combinations here, where the number of combinations being given by that, the sub there. So 0 is the number of combination, and this, the second term, this one is the second term. The power is 0, so we've got 0 and 0 there. The number of combinations here is 1, and we've got a 1 there. The number of combination here is 2, we've got a 2 there. The number of combinations there is 3, we've got a 3 there. The number of combinations there is 4, we've got a 4 there. It's just a pattern which we're making. Okay, and note number 3, the number of terms in the expansion is always equal to n plus 1. Okay, so we said this is n, and then plus 1 should equal to what? 5. So the number of terms in the expansion are 1, 2, 3, 4, 5. So if we had, if we're expanding to, let's say, to the power 7, the number of terms in the expansion will equal to what? 7 plus 1, which is equal to 8. Okay, I repeat. Let's say we're expanding to the power 5. So the number of terms in the expansion will equal to 6, which is n plus 1. 5 plus 1 will equal to 6. Okay, finally, let us simplify each of the terms in the expansion. Okay, so this is the expansion that we've just been looking at in the last board, and we want to expand. Okay, so in expanding this, we pick up a calculator and we punch 4 combinations 0, and 4 combination 0 on the calculator is 1. That's where we're getting this 1 from. Okay, that x raised to power 4 is that one. And then using the laws of indices, we know that anything raised to power 0 is 1 as well. Okay, so that's where that has come from. Let's now simplify the second term. If we pick up a calculator again, 4 combination 1 on the calculator is 4. We've got x to the power 3, which is that one there. And according to laws of indices, anything raised to power 1 is itself. So it's just that. That's what we're getting there. Okay, we now go to the third term. We pick up a calculator and we punch out 4 combination 2. We get 6. We've got x squared there, which is that one. And on that one, we apply the laws of indices. According to laws of indices, the laws of indices say that if you're expanding anything in brackets like that, we're going to raise minus 1 to the power 2. which means we're multiplying -1 multiplied by -1. -1 multiplied to itself twice. So -1 multiplied by -1 will simply give us a +1. And then we're going to have x squared there raised to power 2 as well. X squared raised to power 2 will give us x4. Okay. And then we go to the fourth term. We pick up a calculator again. That will simply give us 4. We've got x to the power 1 there, and we raise that to the power 3, so we're going to have -1 multiplied by -1 multiplied by -1, which will give us a -1. And then the x to the power 2 raised to the power 3 is x to the power 6. And lastly, we expand that one. 4 combination 4 is 1. X raised to the power 0 is 1. And that raised to the power 4, -1 will be raised to the power 4. So we're going to have -1 multiplied by -1 multiplied by -1 multiplied by -1, which will give us a +1. And x squared will be raised to the power 4, which will give us x to the power 8. Okay, now let's finish our simplification. Okay, so the first term, 1 multiplied by that is simply x to the power 4. Here we're going to, on the second term, the negative will multiply by the positive to give us a negative. That 4 is that 4. And then x to the power 3 will cancel out with x to the power 2, leaving us with only 1x. The third term, that multiplied by that one will give us 6. And then x squared divided by x to the power 4, 2 of the x's will cancel out, leaving us with x squared. The fourth term, negative multiplied by positive is negative. We've got a 4 there. We've got 1x on top, 6x's on the bottom. If we cancel out, we remain with 5x's on the bottom. Lastly, we've got 1 multiplied by 1 multiplied by 1, which is simply equal to 1. And we've got x to the power 8 there. Okay, so that is how we simplify this expansion using combinations. Thank you.